We're going to talk about fitting a line to bivariant data using the least squares regression line, commonly referred to as the LSRL. What is the objective of a regression analysis? The objective of regression analysis is to use information about one variable, x, or the explanatory variable to draw some sort of conclusion about a second variable, y, or the response variable. To do so, we're going to use the least squares regression line. The formula for a least squares regression line should look very familiar. It is our linear function equation. So, how the formula is used is we use y hat, which is our predicted y, is equal to our y-intercept a plus our slope times our x value. So how do we get a LSRL? Scatter plots frequently exhibit a linear pattern. When this is the case, it makes sense to summarize the relationship between the variables by finding a line that is as close as possible to the plots in the plot. This is done by calculating the line of best fit, or the least squares regression line. So we're going to find a least squares regression line using our calculators. So I have our 3 points here plotted in our list. It is located in list 5 and list 6. In order to find the least squares regression line, I want to click on Stat, Calc, and then go to a linear regression, which we have been using to find our correlation coefficient. Now make sure that your X list and your Y list is where they should be. And then we also want to store our regression equation into our calculator. To do so, we want to click on vars, yvars, function, and y1. Now once we calculate, our calculator gives us the values for our least squares regression line. Here we can see that our y-intercept is 3 and our slope is 0.33, 1/3 in this case. But you can typically leave it in decimal form. So our predicted y is equal to 0.33, excuse me, 3 plus 0.33x. Now, we are going to discuss whether or not this is a strong linear relationship or whether a linear model is appropriate to use. In this case, we have a correlation coefficient that is well below 0.5. It's 0.19. So this indicates that there is a weak positive relationship between these two variables. Still, we are able to create a linear function using the values that our calculator was able to give us. So, when assessing the fit of a least squares regression line, we do have to ask ourselves some important questions. Is the line an appropriate way to summarize the relationship? Are there any unusual aspects of the data? And if we decide to use the line as a basis for prediction, how accurate can we expect the predictions based on the line to be? In the case of our previous example, this linear model would not be a strong model to use because of the weak relationship between the weak correlation between the two variables. Still, we are able to interpret what is said in the least squares regression line. First, the slope. The slope is the approximate amount by which y increases when x increases by 1 unit. One key concept of this unit is going to be the words approximate or prediction. These are nothing more than prediction models. Therefore, we cannot say that these models will give us an exact amount. We have to always give some sort of indication that it is a prediction. If we do not, then our analysis will be completely inaccurate. Our y-intercept is the approximate amount of y when x is equal to 0. In some situations, the y-intercept has no meaning. Still, it is important to interpret what the y-intercept is. In class, we will discuss formulas in statistics. I will give you two types of formula sheets, one that the AP uses and another that describes in depth what these formulas entail.